Hello everyone, myself Pankaj Sunil Jagtap and I am undergraduate student from Anna Sahib Dange College of Engineering and Technology, Ashta. Today I am going to deliver a short presentation on haptic technology. Before it starts, I would like to thank Professor Sagar Patil sir whose guidance led me to this presentation. So let's start. Haptic technology. In simple words, haptic technology explains how the human sense of touch works by allowing creation of controlled haptic virtual objects. Basically, it refers to any technology that can create an experience of touch by applying forces or motions to the user. Now let's take a look on a history of it. Thomas Massey in 1995 developed the Phantom, that is personal haptic interface mechanism. It used thimble-like receptacles at the end of computerized arms into which a person's fingers could be inserted, allowing them to feel an object on a computer screen. One of the earliest applications of haptic technology was in large aircraft that used servo mechanism system to operate control surfaces. So now let's move to the main topic. What is haptic? What does it actually means? Haptics is the science or technology of transmitting and understanding information through touch. Basically, haptic means anything relating to sensing of touch. The word is derived from Greek word for touch. The sense of touch may be classified as passive and active, and the term haptic is often associated with active touch to communicate objects. Basically, haptic information provided by system will combination of two types, tactile information and kinesthetic information. Practically, tactile information refers to the information acquired by sensors, which are actually connected to skin of human body with a particular reference to spatial distribution of pressure or more generally tractions across the contact area. For example, when we handle flexible material like fabric and paper, we sense the pressure variation across the fingertip. This is the actually sort of tactile information. Tactile sensing is also the basis of complex perceptual tasks like medical palpation, where physicians locate hidden anatomical structures and evaluate tissue properties using their hands. This diagram refers to haptic system. Generally, haptic system consists of two parts, namely human part and machine part. The human part senses and controls position of hand, while machine part exerts forces from hand to simulate contact with a virtual object. Also, both systems will be provided with necessary sensors, processors, and actuators. In the case of human system, nerve receptor performs sensing, brain performs processing, and muscle performs actuation of motion performed by hand. While in case of machine system, above mentioned functions are performed by encoders, computers, and motor respectively. Haptic feedback. Figure shows basic elements present in feedback system. Applications main element are the simulation engine responsible for computing virtual environment behavior over time, visual, auditory, and haptic rendering algorithms, which compute the virtual environment, graphic, sound, and force responses towards the user. Transducers, which converts visual, audio, and force signals from computer. Human operator typically holds or wears haptic interface device and perceives audio-visual feedback from audio and visual displays, whereas audio and visual channels feature unidirectional information and energy flow. The haptic modality exchanges information and energy in two directions from towards the user. Let's move to the haptic devices. By using haptic devices, the user can't only feed information to computer but can also receive information from the computer in form of felt sensation on some part of body. Haptic device is one that provides a physical interface between the user and virtual environment by means of computer. This can be done through an input and output device that senses body's movement such as joystick or data glove. Figure shows that device Phantom. It is a haptic interfacing device developed by a company named Sensible Technologies. It is primarily used for providing 3D touch to virtual objects. This is a very high resolution 6 DOF device in which user holds ends of a motor controlled jointed arm. It provides a programmable sense of touch that allows user to feel texture and shape of virtual object with a very high degree of realism. One of its key features is that it can model free-floating three-dimensional objects. This figure shows device Cyber Glove. There is a simple principle behind Cyber Glove. It consists of opposing the movement of hand in same way that an object squeezed between the figures resists movement of latter. The glove must hence be capable, in absence of real object, of recreating forces applied by object on a same human hand with the same intensity and same direction. Now let's have a look on a future vision of this technology. What is the need of this technology? As the haptic moves beyond the buzzes and thumbs of today's video games, technology will enable increasingly believable and complex physical interaction with a virtual or remote objects. Already haptically enabled commercial products like designers sculpt digital clay figures to rapidly produce new product geometry, museum goers feel previously inaccessible artifacts, and doctors train for simple procedures without endangering patients. If we talk about future applications, there are telepresence surgery, noise-based devices such as randomly vibrating insoles, also spider sense body suit equipped with ultrasonic sensors which alerts the wearer of incoming threats, allowing them to respond against it when they are blindfolded. If we talk about overall cost and demand, we can clearly see here Germany has highest haptic technology market for this technology, while the Italy has lowest haptic technology market for this technology in the range of 2016 to 2026. Haptic technology market size exceeded USD 7 billion in 2019 and is poised to grow at a CAGR of over 7% between 2020 and 2026. Rapidly increasing demand for consumer electronic devices and touch-enabled home appliances is fueling the adoption of haptic technology. Increasing utilization of haptic in cars, mobiles, and IoT appliances to achieve improved product design and operating accuracy will boost the market growth. Several benefits provided by haptic, such as enhanced sound, touch, and visual effect in touchscreen devices, are contributing to its wide adoption in the electronic sector. The vibration feedback provided by haptic technology aids users to improve touchscreen accuracy. So what are the advantages of this technology? How are they helpful to us? Let's talk about this. The first advantage is increased accuracy. One of the greatest benefits of haptic response in touchscreen device is increased accuracy. Also increased input speed. Another benefit of haptics in touchscreen device is increased input speed. Also improved user satisfaction. There are some disadvantages also occur in this technology. It includes complex designing as haptic devices require precision of touch, high initial cost involved. Since this technology is still being rapidly introduced, it has not become very common, hence it is still relatively expensive. Useful cases. Here we list and discuss several ways haptic technology can be used to benefit certain industries. Airline industry. Pilot can feel the buttons and controls during training simulation and mechanics can feel the experience of handling parts to make repairs. Medical industry. Medical student can feel what it is like to perform complex, delicate surgeries. Space travel. Through an advanced haptic robot, scientists will be able to feel what rocks are like on Mars. Military. Haptic technology will teach soldiers how to take apart bombs in a virtual world as well as prepare for battle. In video games, gamers will be able to feel the weight and power of their tools in the virtual world used to play games. In education system, studies have shown that children learn better when they can associate learning experiences with touch. Resources for the disabled. One of the many examples is touchable maps and objects for the blind. So finally, what's the conclusion about this? We shouldn't forget that touch and physical interaction are among the fundamental ways in which we become to understand our world and to effect changes in it. This is true on a developmental as well as an evolutionary level. Our efforts to communicate information by rendering how objects feel through haptic technology and excitement in our pursuit might reflect a deep desire to speak with our inner physically based language that has yet to be given a true voice. Thank you all.